Okay, howdy class. This primer is going to be on list comprehension in Python. Now, list comprehension is a newer Python feature. It was introduced in Python 2, which was some time ago, but nonetheless, it was one of the improvements in Python. And what list comprehension does for us is rapidly compile a list based on either a filtering, a calculation, a manipulation, any of those things. So here's what we'll be doing for this class, delving into list comprehension. Now, here's a good example. Let's say we had just a normal everyday loop. First, let's say that we have a list declared. And let's say that those values are this. And if we simply wanted to output this list in a member-wise fashion, item by item, and not only output it, but then store it in a separate list, let's call it B. So B is our kind of our target list. Well, we could create a for loop that would do that. Let's see, I won't call it val. I will call it, I'll call it I think. So if we remember that syntax correctly, for I and A is the list, and every time through this loop, it will extract the next item in the list and assign that temporarily just for this one iteration of the loop as the variable I. So given that, then if we had a list B that we had made up here, this is an empty list, well, then we could append that value to B. Something like that with the append method. And again, this is our original list here. Every time through, we pull a value from that list and temporarily assign it to I, and then that value will then get appended to this new B list that we're trying to create. So that's sort of the old style, the old school way of doing this, but with list apprehension, we can actually do this in one single statement. We can combine all of this code here into one single statement. So we'll still need that A list as our originator, something to manipulate. But what we can do is just do a kind of a slight reshuffling of this code and make sure the syntax lines up to get list comprehension. So the way we'll do that is we will still keep this syntax here for I in A. So let's just move that over here. Just like that. Now, what we need to look at is what gets returned from that is I, and what are we going to do to that? Now, list comprehension will have sort of two fields that we'll deal with. One is going to be the operation or the formula or the process that we will apply, again, in a member-wise fashion for each of these elements in this list A. So in this case, all we're doing really is repeating that value. So that will go right here. I for I and A. And then what we'll do is envelop this in our square brackets to say that, okay, the data structure created by this new series of elements, we're going to put a wrapper on that and make a Python list out of it. And then let's go ahead and assign that list to the new variable B. So that's sort of the rejuggling of the syntax that happens to make a list comprehension work. Now I've got some code here. This is again in a Python a Jupyter notebook. And that notebook lets us just split up some code into easy chunking segments and just run those one at a time. So now here's the first thing that we'll take a look at. You remember that the old way of doing it was with a for loop. The new way of doing it with list comprehension is going to be, all right, well, here's the for I in A. So this will step through the list A. Every element that gets extracted from that will be temporarily assigned I, through each iteration. And then what do we do with that? What do we process? Well, the only thing that we process here is we repeat it. We have, we're just going to present it back as I. Now then this process, since we are bounding it with square brackets, means that whatever this output becomes, we're going to make a Python list out of it and assign it to B. Then here in this statement, we process this list by printing it. And there's our output there. Let me run it again, and you can see here that output is exactly the same as the original input list of A. Okay, so this is great. We could use this kind of compacted syntax for repeating an array or copying an array. This is tantamount to just simply copying an array. But let's try something different now. Let's do it where rather than simply having the value repeated here in this I for I and A, again, the first I means what operation will we perform on each element of this list. This time, let's triple the values. So here the operation is I times 3, and we still do for I and A being the original list, I being the value we extract every time we go and iterate through that list. So when we run this, we see that the output is exactly triple of what the original array was, which the original list was. So pretty cool. List comprehension, again, lets us rapidly compile a new series of elements into a list based on some operation that can be applied to some other list. Now, let's get a little bit further into this. Now, if we remember right, this cell here is going to take a look at sort of the old school way that we would use nested loops to process some type of data. So now in this case, we're going to have a Python list called M. We'll declare it as the empty list to start. And then we're just going to put it through these two for loops, and they're nested. The first for loop is going to go from 1 to 3. The second for loop is going to go from 2 to 4. And then every time through that, it's going to simply multiply those two values together and then append that to the M list. Pretty straightforward. We can see here then that the output, and let me run this, is in fact all of this. So that's going to be a 1 times 2, and a 1 times 3, and a 1 times 4. And then we increment I, a 2 times 2, a 2 times 3, a 2 times 4, and then a 3, a 3, a 3. So now that's the old way with nested loops. However, we can combine all of that code, all 4 of those lines, we can compress that into a single line of code using list comprehension, you guessed it. Now we can do nested loops in the exact same way that we would do a single loop. So here is the single loop for I in range 1 to 4. But then if we repeat that for j in range 2 to 5, that's the nested loop. And then what happens? Well, every time through that, we're going to apply this function. And we're simply multiplying I times j. So here's the I in that first loop. Here's the j in the second loop. And when we apply this formula to it, I times j, we get actually the exact same results here as the old school way of processing this with nested for loops. So carefully take a look at this code that I've posted here. I've posted it just in a normal Python script. You can run it and then just see the output. And carefully check that and just make sure that you really, really grasp just how this rearrangement of syntax occurs, especially in something a little bit more complex as a list comprehension on nested for loops. Now, this next little demo shows that we can actually use list comprehension to filter out some values. What that means is that we can do the same type of operation that we did, I times 3 or whatever for I and A, but list comprehension lets us put in a clause as an optional addition at the end of the list of arguments in the list comprehension. So let's take a look at that. First, let's look at an old school way right here of how can we filter our original list and just get values that are greater than 5. Just get values greater than 5. So now A, remember, is our original list. Let me scroll way up here. And that's still our original list. And the way Jupyter Notebooks runs is that if you run this first, well, then that A stays resident in memory and we have access to it for this session. So this loop here is going to be for every element in A. Then we'll ask a question. If that element happens to be greater than 5, well, then we're going to append it to B. So we run this, and of course, just a couple of these values here are greater than 5, and it's 6 and 7, you see there. So we get those values output right down here. And we get actually 6 and 7. Okay, well, we can then combine that just with some rearrangement and format it as list comprehension. So let's take a look at that. Here's the new school way of doing it. So here's the full line of code that's going to produce the exact same thing that we just saw above it. Or in other words, it's going to collapse those 4 lines of code, boom, into just a single line of code using list comprehension. So let's take a look at it. Here's the for X and A. We understand that. We understand X for X and A. X means the formula that will be applied. And since there's no formula, it's just listing X, then that is just going to be repeated. But now look at this extra clause we have at the end here. It's a conditional clause saying if and only if X is greater than 5, then will we do this whole operation. So we run this and you see that we get the exact same results here, 6 and 7, as we got above with that old school for loop. So again, we have to kind of parse this and remember, okay, the key part of this is for X and A. That's the first element of this list comprehension that's required. That is going to kind of give us the engine of how to go about processing it. The second most important piece here is, well, what formula will be applied to each of those elements? And then now this conditional clause kicks in saying, okay, only do values that are greater than 5. So it's a filtering operation. So let's do that same thing here. I want to create a list here of values from -5 to 5. So we can just use the range function, wrap that up into a list, and assign that to C. Okay, so that's our beginning list here for this next little segment of code. So if we print C, we see that it gives us this big list here from -5 to 5. Just like we want. Okay, well, let's take an attempt here and filter out just the negative values. So we have this big long list. We want just the negative values. And we want to use list comprehension to do so. We know that we could do, probably a 4-line minimum for loop to make this happen. But with list comprehension, we want to make it happen just in one in one line. And oh, by the way, we want to take those results, whatever gets returned, and assign it to a new list called D. So here is that code. I've got it highlighted there. And again, here is our for val and C, that's the core part of the list comprehension. This is the for loop part. Val is just going to repeat the variable. And then, oh, by the way, there's this little caveat. Only do this operation if the value that we extracted happens to be negative. So we run that and we see here, yep, we get the -5, 4, 3, 2, all the way up to -1. Now, list comprehension doesn't work only on integers or floats. It can actually work on strings too. This next little cell is going to let us explore how to work with some strings. So here is a names list with a variety of names, some beginning with uppercase, some beginning with lowercase. And what I want to do is extract all of the names here that begin with a C. And it doesn't matter if it's a capital C or a lowercase c, I don't care. I just want it to begin with a C. So using list comprehension, we can do that in one single statement. Let's take a look at this. Okay, first let's look at the for loop for n in names. So it's going to go through this names list here. And every time through it, it's going to extract a string and assign that the temporary variable n. Now, all we're going to do here is repeat n. So whatever n is, it's just going to be input into the new list. However, there's this new caveat, this if statement here, saying, okay, only if the name starts with a C. And this is how we would code it. We'd code it in a couple of steps. First, let's take that name, n, and convert the whole thing to lowercase. Just outright convert it to lowercase. So we're only dealing with lowercase comparisons, and we don't have to wrestle with uppercase. So n.lower is going to take that entire string and lowercase it. And then the starts with method will do exactly what it appears to do. It will filter out just those elements that start with the lowercase c. But remember again that this will capture items that begin with uppercase C in the original list here. It'll capture those because we are going to convert them first before we do the comparison to check to see if that first element or that first letter is a C. So when we run this, we see, yep, we get all of the C's here. We get Charles, Carrie, and Casper. And notably, we got Carrie, even though that name starts with a lowercase and the others start with an uppercase. Now, here's an example where we can actually combine these operations using logical operators. We could make a more complex logical function. So in this case, I want to just get the names that start with a C or a D. Doesn't matter if they're uppercase or lowercase. So this code here is exactly what we had before. Except I'm going to expand this if statement now, where we have two clauses, if A or B. So the A part of that is the same if this or this. And this is just simply checking to see if the case is a D. So here you can see in the output then, we get a lot more output, but only those elements that begin with a C or a D. So the Evelyn element was left out. Now, as our final demo here, here's a good example of what it's like to take a two-dimensional Python list that I'll call E here and flatten it into a one-dimensional list. Now, yep, we could do nested for loops, go through this, extract an element, and then append it to the empty list F. But you guessed it, with list comprehension, we can do this in one single statement, and it's this here. Y for X and E for Y and X. Got it? Does that make sense? Let me say it again. Y for X and E for Y and X. What? All right, let's parse this a little bit. You ready? The first thing that we always look at is the first for loop for X in E. So let's recall what E is. E is a Python list that contains lists. It's a list of lists. So a single element in E here is not a number, but it's actually a list. So E has got 3 elements in it. The list, 1, 2, 3, the list, 4, 5, 2, and the list, 3, 2, 6. So if we extract a single element, it's going to be the list. So this right here is going to return a list. So X is going to be a list. And specifically, X is going to be that 3-element list, and it'll rotate through every time we go through the list. All right, so at this point in our hand, we've got X as a list in our hand. This second for loop says, okay, given X, let's extract a value through it. So it's going to go through that and each time extract a Y. So the first time through a Y, the second time through a Y, third time through a Y. So that Y gets declared, and here all we're going to do is repeat that. So that's what that first Y is for us. It's the operation that we perform on the value that was ultimately extracted. And here we're simply repeating it. So what this means then in the context of assigning it to an F, and we've got braces around it, is we're creating another list. So we run this and we see that our code gives us that flattened list into a single one-dimensional list, a 2D into a 1D. And that's pretty cool. Again, we could code this, probably take 5, 6 lines or so, but this is a nice, easy way to do it in a single line using list comprehension. Okay, hope this helped everybody, and please post questions to the discussion board, and as always, message me if you have questions, or drop in for office hours on Friday and we can discuss. All right, thanks everybody.